Good morning. Today we will see the types of linked list. Before seeing that, we will have a brief view about what is a linked list. A variable. In a variable, we can store only one data. Next comes the array. In an array, we can store a collection of data, but the size has to be predefined. It is static. Whereas in a linked list, we can store collection of data, but the size is dynamic. We can store how much ever element we want until the memory becomes full. In a linked list, the elements will be stored in a node. This is a node. A node contains two parts. One is the data part and this is the link part. For example, let us insert an element 10. This element 10 will be inserted in the data part, whereas the link part contains the address of the next node. There is no other node, so null will be stored here. Now we will insert a sequence of elements 2, 10, 8. There are 3 elements, so we are creating 3 nodes. These nodes will be linearly linked. In the data part of the node, insert these elements 2, 10, 8. For our convenience, let us consider the address of this node to be 100, this to be 200, address of this node to be 300. So this link part, what does this contain? This contains the address of the next node, that is 200. This part, link part contains the address of the next node, which is 300, so 300 will be stored here. There is no other nodes left, so null will be stored here. To access this list, we have to know the address of the first node, which is 100. This address 100 will be stored in a pointer. This is called the header. Now we look into different types of a linked list. There are totally 4 types in a linked list. First is the singly linked list, doubly linked list, singly circular linked list and doubly circular linked list. In these two cases, singly and singly circular linked list, a node takes 2 parts. As we have already discussed, this part is the data part and this part is the link part, which contains the address of the next node. Whereas doubly linked list and doubly circular linked list, in these two types, a node takes 3 parts. The center part contains the element that we are going to store. The first part contains the address of the previous node. The last part contains the address of the next node. Now we will look into how these two nodes will be represented. For example, let us insert an element 5, where this 5 will be stored in the data part. So the data is of the type integer, and here the address is stored, which is of a type pointer. Both these are variable, but not of the same type. So a user-defined type structure will be used. Struct node. First is the data part. So int data. Next is the link part where the address will be stored. here struct node, the address of next node will be stored. So next, close. In W and W circular linked list, a node takes 3 paths. This is also a link path which takes the address of the previous node. Only a mild change should be taken place, that is struct node open. Before the data part, there is a link part which contains the address of the previous node. So, struct node previous. This part is represented here. Then comes the data part. Then this part which contains the address of the next node. This is how linked list will be represented in all the 4 types. First is the singly linked list. This is a normal linked list where a node takes 2 parts, one is the data part and another is the link part. Data part contains the element that we are inserting and the link part contains the address of the next node. Traversal. Traversal takes place only in the forward direction. Next is the doubly linked list. In doubly linked list, a node takes 3 parts. The first part contains the address of the previous node. The second part, data part, contains the element that we are storing. And this part, the third part, contains the address of the last node. Traversal. Traversal happens both in the forward and in the backward direction. Next is insert or delete. Insert or delete operation in doubly linked list is difficult when we compare it with the singly linked list. Next is the memory space. The memory space required to store a node in the doubly linked list is larger when we compare it with the singly linked list. Next is the singly circular linked list. Before going into this, we will just have a comparison between singly and singly circular linked list. In singly linked list, the link part of the last node is null, whereas here the link part of the last node contains the address of the first node because it is circular. The traversal happens only in one direction. Header. If we are going to include a header here, then this pointer has to point to header and not to the first node. Next is doubly circular linked list. Now we will compare the doubly and doubly circular linked list. The first part of the first node is null and the last part of the last node is null. Whereas here the first part of the first node contains the address of the last node and the last part of the last node contains the address of the first node. Traversal happens in all the directions. Now let us see the time complexity in a linked list. Insertion takes order of 1 time complexity for both average and worst case. This is because in linked list we can store how much ever elements we want until the memory becomes full. Linked list is dynamic in nature. Next is deletion. Deletion also takes order of 1 time complexity. Let us discuss deletion in both array and linked list to get a better understanding. There are 3 elements 2, 10, 8 and now we are going to delete the element 10. If we are going to delete element 10 in array, then 10 will be deleted and 8 will be moved 1 cell before. Whereas in linked list, 10 will be deleted and it is not necessary to move 8 before. This is the difference. That's why linked list take order of 1 time complexity for deletion. Traversal takes order of n time complexity for both average and worst case. Let us see this with an example. We are going to search 8. In an array, each element will have an index value. In our example, there are totally 3 elements. That is, there are totally 3 data. The first data will take an index value of 0. Second data will take an index value of 1. And the third data is 2. If we want to search 8, just by indicating its index value, that is 2, we can directly access 8 without disturbing the element 2 or 10. But in the case of a linked list, if we want to search 8, first step is we have to locate the first node. Locate first node. And second step is refer to link path or the address. First, we have to locate the first node. Then, by referring to this address 200, we have to locate this node. Then, by referring to this address 300, we have to locate this node. Only then we will be able to access the element 8. That is why traversal takes order of n time complexity.